This is page 35 and 36 in your Unit 10 packet. This page is actually 35. It's talking about quadrilaterals on a coordinate plane. So whenever we plot quadrilaterals on a graph, we prove which quadrilateral they are. So it says we use properties of quadrilaterals or parallelograms to classify our shapes. Since a parallelogram has two pairs of parallel sides, we can use slopes to prove a figure is a parallelogram. Given quadrilateral blue, where B is here, L is here, U is here, and E is here, prove that blue is a parallelogram. So the first thing we have to do is plot our points. So B is -4, -2. Where's B? L is -2, +2. U is 4, 3. And E is 2, -1. And this is what we believe is our parallelogram. We have to prove it to be so. So first of all, let's see if the BL slope and the UE slope is the same. So BL, the slope of BL is rides over 1, so 1, 2, 3, 4 over 1, 2, which is 2. UE is 1, 2, 3, 4 over 1, 2. So far it checks out. And then we do the slope of LU and the slope of BE. This one goes up 1, so 1 over 1, 2, 3, 4, 5, 6, 1 over 6. And then BE is up 1 over 1, 2, 3, 4, 5, 6, 1 over 6. So these match, and these match as well. So yes, it is a parallelogram because it has two pairs of parallel sides. Once we know a quadrilateral is a parallelogram, we can use other properties to prove if the quadrilateral is a special parallelogram. Remember that parallelograms could also be rhombuses, rectangles, and squares as well. Since a rectangle has congruent diagonals, we can use the lengths of the diagonals to prove it is a rectangle. Given quadrilateral hair, where H is here, A is here, I is here, and R is here, prove that hair is both a parallelogram and a rectangle. So H is at -1, 2, 3, 4, -1. -1, 2, 3, 1, 2 is A. 1, 2, 3, 0 is I, and 1, 2, 1, 2, 3 is R. So first we have to prove it's a parallelogram, so we need to find the slopes. So first let's do the slope of HA and the slope of IR and see if they match. So HA goes up 1, 2, 3 and right 1, which is 3, and then RI goes up 1, 2, 3 and right 1, so 3 over 1, which is 3. So that does check out. And then we have to check the slopes of AI and the slope of HR. it goes up 1, 2, and left 1, 2, 3, 4, 5, 6. So 2, 6, and it goes left, so it's a negative slope. That reduces to negative 1/3. HR goes up 1, 2, and then 1, 2, 3, 4, 5, 6. So 2 over 6, and it goes left, which makes it negative. That means it is negative 1/3. So those slopes also work. So yes, we do know it is a parallelogram. I'm going to take these off to show the next part. But now that we know that it is a parallelogram, we have to see if it is a rectangle by the lengths of the diagonals. So is this length the same length as this? So we have to find the length. If you remember, we do this by right triangles. So we're going to make a right triangle out of a R. So we're going to do this one first, that first diagonal right there with the red right triangle. So this one is 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So for AR is 5 squared plus 5 squared, and take the square root of it. What is that length? So second square root 5 squared plus 5 squared. It is 7.07. Okay, let me take all this red off, and we got to do the other diagonal. So this one right here. What's the length of that one? So it's 1 here, and 1, 2, 3, 4, 5, 6, 7. So 7 and 1. So HI 7 squared plus 1 squared. Square root of 7 squared plus 1 squared is 7.07. So that both of those work as well. So yes, this is a rectangle as well as a parallelogram. So 2 pairs of parallel make it a parallelogram. And 2 congruent diagonals make it a rectangle. Okay, let's go on to the next page. Since a rhombus has perpendicular diagonals, we can use the slopes of the diagonals to prove it is a rhombus. Given quadrilateral home where H is there, O is there, M is there, and E is there, prove that home is both a parallelogram and a rhombus. So first, plot it. H is at 0, 1. O is at 1, 2, 3, 4, 1, 2. M is at 1, 2, 3, 1, 2. And E is at 1, 1, 2, 3. Okay, so the first thing we have to do is prove that it is a parallelogram. So parallelogram, yes or no? So let's do the slopes of this side. So the slope of HE and the slope of OM. Let's see if they match. HE goes up 1, 2, 3, 4, and right 1, which is just 4. And then OM goes up 1, 2, 3, 4, and right 1. So far those match. Now let's do the slope of HO and the slope of ME. It goes up 1 and right 1, 2, 3, 4. ME goes up 1 and goes right 1, 2, 3, 4. So those match. So yes, it is a parallelogram. Now let's see if it is a rhombus. So to do that, we need to find the slope of its diagonals. So these two lines here. So first, the slope of OE, which is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's just 1. Then the slope of HM, which goes up 1, 2, 3, and left 1, 2, 3. So 3 and left 3 makes it negative. And negative 1, remember that the slopes are perpendicular, so they have to have opposite reciprocal slopes. And in this case, since it's 1, and the opposite reciprocal slope of 1 is just negative 1. So yes, this is a rhombus. What is the product of the slopes of the diagonals? So what is 1 times negative 1? Negative 1. Since we know the squares are both rectangles and rhombi, we can prove it is a square by showing that the diagonals are both congruent and perpendicular. Use the diagonals to determine whether a parallelogram with the given vertices is a rectangle, rhombus, or square. Give all the names that apply. So we already know it's a parallelogram because it says it right here, so we don't actually have to find the slopes of all the sides. It tells us it's a parallelogram. So first thing we need to do is plot. 1, 2, 3, 1, 2, 3, 4, 5. So that's P. 1, 2, 1, 2, 3, 4, 5, 6, 7. That's I. 1, 2, 3, 4, 1, 2. That is N. And then K is negative 1, 0. So K. So first let's figure out if it is a rectangle. So are the diagonals congruent? So we have to find the length of the diagonals. So what is the length of PN? Here is our triangle. And that's 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7. So the square root of 3 squared plus 7 squared. Okay, so the square root of 3 squared plus 7 squared is 7.62. Then we need to do the distance of IK. So this is 1, 2, 3, 4, 5, 6, 7. This is 1, 2, 3. So the square root of 3 squared plus 7 squared, which we just did above, is 7.62. So yes, it is a rectangle. The next thing we need to try to prove is whether it is a rhombus. So remember, for the rhombus, we see if the diagonals are perpendicular, so we have to find the slopes. So the slope of PN, it goes up 1, 2, 3, and it goes left 1, 2, 3, 4, 5, 6, 7. Up 3, and left makes it negative 7. Then the slope of IK goes up 1, 2, 3, 4, 5, 6, 7, and goes right 1, 2, 3. So 7 over 3. The opposite reciprocal of negative 3/7 is a positive 7 over 3. So yes, it is a rhombus. And since it is both a rhombus and a rectangle, that makes it a square. Now what you can do is pages 37 through 38 in your packet that goes with these. That's the end of the notes for today.